Hello everyone. In this video we are going to use our normal distribution and we're going to start seeing how we can calculate probabilities with it when we are given specific cutoff points in scenarios. So first of all, we're going to use this kind of little visualization tool to show how we can have a specific z distribution and how we can look at the standard z distribution and how we can get different probabilities. So let's go ahead and use our scenario that we had in our previous examples. So we're going to set this at 120, 20, and 1. For right now, we're only doing sample sizes of size 1, and we will move and change that as we go on through further weeks. But for right now, we're just looking at a single observation at a time. Okay, so let's say that this is our scenario where we have a mean at 120. So our mean is at 120, here we go, and a standard deviation of 20. And we can also model this with a standardized z distribution if we set the mean at 0. And instead of talking about the raw movement away from the mean, if we talk about it in terms of number of standard deviations away from the mean. But let's go ahead and look at some cuts. So let's suppose that I want to know what's the probability of having a score between a 125 and 175. So if I put in here 125 and I put in here 175, I get that the percent shaded is about 40% or 0.398. And we can see that it's the same regardless if we use a standardized z distribution or if we use a specific z distribution. Now, there are a few things that are different between these graphics, like the scale on the x-axis and the scale on the y-axis are different, but that's just to size it correctly. The area between these points are the same. Now, notice, look, we can also calculate the z value for each of these, and the z value calculation is going to be the same if we use the percent shaded as well. So it's only recorded here once. Let's look to see how we can do this using our Excel tools, and we have it labeled up here as our norm.dist. So let's say that I really do want to know, using norm.dist, what it does. Well, norm.dist, let me kind of give you just a visualization. Norm.dist only gives, for example, areas to the left of a specific cutoff point. So if we say that this is 150, this norm.dist is only going to give you the area to the left. That's what norm.dist does. Now, this right here actually gives you the area between these 2 points, but norm.dist used on its own says from a point all the way to negative infinity, all the way going towards the left. And let's see what happens when we do this. So if I go in here and I say equals norm.dist, and I have that my right cut here is 150. It then asks me for the mean and the standard deviation. So I'm going to put the mean at 120 and the standard deviation at 20. And then it asks for, do we want cumulative distribution function or the probability distribution or the probability mass function? And we choose those between true and false. For this class, we're always going to use the word true. So just use the word true here, and we hit enter. And notice that we got this area to the left. So you might ask yourself then, it's okay, how then up here do we get this area between our two cutoff points of 125 and 175? Well, what we can do is we can take the area from 175 to the left and subtract from it the area from 125 to the left, and then we have the area between these two. So this is going to be, let's just do a little probability statement, probability of less than 175. We write this as a probability statement, put our x as our observation, and then we can do another one, the probability of x being less than 125. And let's run that one too. We can do norm.dist of our 125, comma, our mean of 120, comma, standard deviation of 20, and cumulative of true. And we can hit enter. That gives us our lower from 125. And now we can say the probability of being between. So if we write this out, probability of 125, x is greater than that, but less than 175. That's how we write out our probability distribution. We then say that it's this less than 175 minus the less than 125 And that leaves us with just the area between the two. That's how we calculate it here using our norm.dist. Now, if you notice that I used my raw values here, but we notice here down here on our standard z distribution, notice how it's the exact same area shaded, but we're using different points. And instead of talking about the raw distance from the mean, now we're going to talk about the number of standard deviations, and we get the exact same answer. So if we do norm.dist, and instead of using our x values, we're going to use our calculated z's. And if we use our z's, we get to use a mean of 0 and a standard deviation of 1, because that's how the standardized normal distribution is defined. And then we can just use the word true, and notice that from here, we can say less than, I have this one in the wrong spot. Let me drag that down. Sorry, I did the 125 first. Less than 125 is, so if we go less than 1/4 standard deviation above the mean, which is where we are, it's like almost 60%. And then for the 175, we can do equals norm.dist. And notice we want to know less than 2 3/4 standard deviation above. So here we go. We can do 2 3/4, comma, and since now we're doing the z distribution, we get to use the standardized z distribution. We get to use the standardized mean and standard deviation of 0 and 1. Say true again. And we get the same value. And if we subtract those from each other, we are going to get this same value. So norm.dist is really cool. We can either use it with raw values, or we can use it with just our standard normal distribution when we use it with the z distribution. So that's really cool. We can use our probabilities to find lower than a value, we got those, and between values. But we can also find it when it is, what about if we want greater than 175 or greater than 125? Let's do both of those. So if I want the probability of our random event being greater than 125, or if I want the probability of our random event, being greater than 175, I can do those. But remember, the norm.dist only gives the probability from the point and less than. If we want greater than, we can take a complement. Or what we can do is we can say that is going to be equal to 1 minus the probability of x being less than 125. We can do the same thing, 1 minus probability of our random event being less than 175. This is what is called a complement. And we have to do this when we are using our norm.dist in order to find the area above a particular point. So we just say equals 1 minus, and we have this already, these probabilities. So the probability of less than 125 is roughly that's 60. So the probability of being greater than 125 is like 40%. And then here, the probability of being greater than 175 is going to be equal to 1 minus the probability of being less than 175. And there we go. Now we know how to find the areas of being to the right of a value. And what's neat is that if we were then to find the areas between using this direction as well, we could look at the difference between those, and guess what? We get the same answer, because now we're just, instead of looking at it from between to the left, we just did between to the right, and we get the same answer. So now we have some ideas of how we can use our normal z distribution. And notice here that when we are saying like this probability, we literally are meaning the percent of the area of the graph shaded. So if we look at this z distribution, let's just look at the probability of being between this 125 and this 175. The answer is roughly 40%. And if we look at this graph, we can say like, yeah, roughly, if we look at this area under our curve, roughly 40% of it has been shaded. And that's what we are doing here when we are using our norm.dist, and we are trying to find probabilities using our normal distribution with one sample at a time. I hope that helps out.